modern digital computer logic operations are based upon the laws proposed in the work of George Boole. Boolean arithmetic recognizes only two values or levels, represented by 1 and 0. Constants have a fixed meaning or value or quantity. For example, the number 4 always means the same thing. In conventional algebra, there are many such constants such as integers and all fractions. In Boolean algebra, however, there are only two possible constants, 0 and 1. These constants describe the allowable voltage levels on a wire or the current carried by the wire. Variables. This is a value or quantity that can change or vary. Since there are only two constants in the Boolean system, the variables can only assume one of these two values. The variable whose unspecified value is either 0 or 1 is denoted by the letters capital A, capital B, capital C through to capital Z. These can be upper or lowercase letters, most often seen using uppercase letters. If a variable is inverted or knotted, then this has a bar across the letter. For example, another way of saying this is since there are only two possible levels, if the level is not 1, it must be 0, or if the level is not 0, it must be 1, as seen in the example here. The three main operations are AND, OR, and NOT. The AND symbol represents the two inputs and one output, as you can see here. This is summing two actual inputs. The OR gate, which is represented by what looks like a Star Trek symbol, is an either or. And the NOT gate is represented by the triangle with a circle in the front. The binary number system, known as base 2, as there are only two values, 0 and 1, is used in computer logic. Here you can see the counting system in binary on the right and decimal on the left. You will notice that there are only two values in the base 2, which is 0 and 1, which count for all of the number additions. Then we're moving on to actually binary counting, and you'll see that we start at the right and move left when we count up, and each of the columns is represented by a place value, as you can see here. An excellent way to get familiar with binary counting is the Cisco's binary game, which is available online and also to download. And you'll see here it's a bit like a kind of Tetris build-up game where you have to work out either the binary value representation or using the decimal figure and work out the binary. And then from this you will actually be able to get more familiar with the actual binary system. Now moving on to binary addition. In binary, the highest number is used as 1, so consider the addition of another 1 to the following number below. When 1 is directly under 1 in the binary system, the sum is 0 and a 1 is carried to the next column to the left. If there's already a 1 in that column, then the sum again is 0 and carried again to the left, and so on.